Hi there, as a part of AgilePoint's version 10 release, we're happy to announce support for OpenAI. Now, over the course of this video, we'll first show you how to connect to OpenAI using an AgilePoint access token, and use a sample application to ensure you understand how to use the various activities in the OpenAI activity group. So to create our access token, we'll move into Manage. Under App Builder, you'll see Global Access Tokens. So what I'll be doing here is creating a globally reusable access token for OpenAI, which has its own permission framework. Bear in mind, we can always create an app-specific token. Okay, so let's go ahead and search for OpenAI. Okay, so I'll go ahead and give the name of my token. The API key is the one detail I'll need from OpenAI. And if you're creating this access token for the first time, you would then test the connection and optionally have the ability to specify the model this connection will use. Now, though you have the ability to specify a given model on a per application or per activity basis, this feature here is really handy from an overall manageability perspective going forward because it centralizes model changes to one single place as opposed to going through various applications and activities and updating the model manually. For now, let's go ahead and back out. And from here, we can start to take a look at both our sample application as well as the OpenAI activities included in the version 10 release. Okay, so as you can see here, OpenAI is a bit unique in terms of the typical AgilePoint integration in the sense that there are both activities I can layer directly into the process, as well as the AI control tower. So first, let's take a look at the process activities. We have Analyze an Image, Chat Completion, which we'll use as a part of this application, Create an Image, and Text Moderation. Now, from a control tower perspective, which as we all know is a lightweight AI-driven process overlay that has context around the entire process as opposed to being plugged in at individual spots within our process, we have a very similar set of activities with a few additions. Analyze an image and adapt the flow, analyze an image and insert an ad hoc task, analyze image and initiate subprocess, and analyze image and send notification. Down below, we also have a chat completion activity, as well as a set of chat completion activities to adapt the flow, inject an ad hoc task, initiate a subprocess, and send a notification. Now, today's use case is called Document Intelligence, and what this application essentially does is it compares the key details, clauses, and requirements across multiple versions of a legal agreement. So as an example, a customer might have signed up under initial contract terms, and during a subsequent purchase, those terms may have changed. So this application will validate the differences between the two and use a number of sub-processes to update downstream customer systems of record. Now, in our first human activity, we'll submit a new document for processing. In this demo, we're going to analyze both a statement of work or a license agreement. The next activity will convert that document into text, which our large language models can use. And as a next step, it's going to feed into our classification agent in charge of understanding the document type and as a result, activating the appropriate track. So let's take a look at the configuration. Okay, so now we're using the chat completion activity. I've selected my access token, and in doing so, you'll see here this option is unchecked. The reason behind that is because I did not prescribe the model at the access token level. So as a result, I can select from the dropdown here various models. But as we discussed earlier, using this really helps in overall maintainability of your applications by centralizing model selection, again, at the access token level. Now, there's a number of other model parameters that I've set up here, but let's take a look at the system instructions. Okay, so the goals and mission include classify the provided text into one of the predefined document types, statement of work, license agreement, customer feedback, or other. Now you'll see here an option called Save to OpenAI. This would essentially save these system instructions as a template back to OpenAI. In addition, you're seeing here a warning to verify model token lengths with your provider before configuring the system instructions. Because depending on the model that you choose, there could be different context limits, and all of these would be counting towards that limit. Now, from a skills perspective, we're going to identify contractual, legal, and service-related language. We're going to distinguish formal agreements from informal feedback, detect scope, licensing and customer sentiment patterns, and make a deterministic classification decision for later automation use in our application. So the input is going to be a block of unstructured text submitted by the user or another system. That text may be complete, partial, or mixed in content. The instructions include analyzing the text carefully, classifying it into a number of categories. As we discussed, this is statement of work, scope of work, deliverables, milestones, and timelines, roles, responsibilities, and acceptance criteria, and pricing tied to these services, project execution or statement of work references. Now, from a license agreement perspective, this would be license grant or usage rights, restrictions, intellectual property ownership, term, termination, warranty, and liability clauses, and references to licenses, subscriptions, or terms and conditions. Now, there are other details here for customer feedback, which we won't cover as a part of this video. Optionally, I could add quality verification step, but as you're seeing here, I haven't configured that. And the output, right? Returning one of the following as plain text: no JSON, no markdowns, no extra words or punctuation, a statement of work, a license agreement, customer feedback, or other. Now, in my case, the incoming message is going to be the entire document text itself, but if there were specific values that I wanted to pass, I could always map that here with the schema mapper. Now, the response will be the classification of that document, which we'll store here in a variable called category. Okay, so let's take a look at our license agent. So again, here I'm specifying how I've connected to OpenAI. I've selected my model and my model parameters. Let's take a look at the system instructions themselves. So again, same disclaimer here across the bottom as you'd seen previously. In this case here, our goals and overall mission include accurately extracting structured metadata from a license agreement to facilitate legal document analysis and compliance tracking. The skills include legal document parsing, identification of key clauses and metadata, structured data extraction, and JSON formatting with standardized keys. The input will be the entire agreement text itself. Various instructions: document parsing, key data extraction, agreement ID, effective date, jurisdiction, and so on. Validation checks, special handling, error handling, etc. Now again, I don't have any quality verification configured for this step, and the output is going to be a JSON structure. Moving over to the incoming message, again, the entire agreement text will be passed, though I do have the option to pass specific values. And from a response perspective, you're seeing the JSON structure has been extracted from the output tab that we've just walked through. So now it's a very simple schema mapping. And you're seeing that mapping. Now we do have an SOW agent. It has the exact same configuration, so we won't go through that. But as you're seeing here, from the SOW and license agreement agents, we have a subprocess. So let's go ahead and quickly walk through that. So if you recall, the intent behind this application is to compare any changes in a newly executed agreement versus any prior agreements. So these subprocesses will use AgilePoint integration and query activities to essentially make a comparison. What are the differences between that newly signed agreement and what's currently stored in existing customer systems of record? And we'll present a comparison side by side by bringing a human into the loop. So that was our SOW subprocess. As you're seeing here, the license agreement subprocess works the exact same way. So now that we understand the application in design mode, let's go ahead and run it. Okay, so here's our form, and as you're seeing here, we'll upload either a statement of work or a license agreement. All right, now as you can see here, I have uploaded a license agreement. So let's go ahead and kick this off. So moving into our process tracker, a process has now kicked off behind the scenes. So we've submitted a new document for processing, converted it into text, and our classification agent has correctly identified that this is of a type license agreement. So we can expect to see the license agreement subprocess activate in just a moment. Let's take a look at that subprocess. Okay, so now the process is extracting the details stored in my downstream systems of record, my CRM, in this case Salesforce, and is now going to give us an interface where we can validate the differences side by side via human task. Okay, so we're ready to review. So let's go ahead and open up this task. All right, so the various agents have correctly identified the account in Salesforce this agreement pertains to. I can view the agreement here in line. Agreement name, key details like licensor versus licensee, and the respective addresses. But all the action is going to take place here under the metadata comparison screen where, as I mentioned, we have a side-by-side comparison with visual cues highlighting key areas of discrepancy. The signatories, and then finally the action screen. So here in this case, based on what we found in the agreement, the best course of action would be to update our systems of record with the key details from that newly executed agreement. But as you're seeing here, I could have the option to trigger a new contracts management flow simply by uploading a new agreement or effect no change. Okay, so let's run this application once more. Okay, so running the application once more, let's bring it up here. This time we'll upload a statement of work. Okay, so as you're seeing here, I've now uploaded the statement of work, and let's go ahead and kick off the process. Okay, so a new process instance has just kicked off. Our classification agent has identified this as a statement of work. So again, we'll see the extract running here for another second or so before the sub-process is activated. Okay, let's take a look at the sub-process. Okay, now the human task is ready to go. So going to be a very similar experience here. Again, the account details have been identified. The statement of work document is here in line. Service provider and client name. And then again, moving over to our metadata comparison, we can see there are a few differences between the new agreement and what's stored in my existing system. So as a result, we can use our navigation buttons here towards the bottom to move to the action section where we have the same potential outcomes. Okay, so that's going to conclude the content for this video. Thank you so much for watching. I hope that now gives you a better understanding of 1, how to connect to OpenAI, and 2, use a few of the process activities as a part of your next application. Thank you so much for watching. Talk to you soon.